Lunch. My name is Konstantin Baibakov. I'm a mission scientist at the Canadian Space Agency, which is actually just located on the south shore of Montreal. So Montreal is home for many of us here. I'm also the mission manager for the Arctic Observer Mission and speaking here on behalf of the team. And 10 minutes or 12 minutes is certainly a very short time to get into any kind of details. So my goal is rather to get you curious about the mission and get you possibly intrigued about the mission if you've never heard about it. And for those of you who have heard about it, just provide a little update of where we are and where we are going with the next steps. So just a little bit of a context. I don't think I need too many arguments to convince you that despite the fact that the Arctic is only sparsely populated, it certainly has a profound importance to all of us because it has important influence on the global climate. In fact, this is, of course, the fastest warming region on the planet, warming at the rate of 2 to 3 times than the global average. And these temperature changes would affect other elements of the Arctic system, including sea ice extent, atmospheric composition, and permafrost. And the permafrost is actually, of course, an important one because it contains almost twice the amount of carbon than the atmosphere. And it is estimated that carbon will be released as CO2 or methane in certain quantities, which will only make the situation worse. So in this context, we really need a robust system that allows us to observe the entirety of the Arctic region. And if we're talking about such rapidly changing phenomena as weather, we also want a high temporal resolution. So if we turn to satellites, we usually have only 2 options. One is low Earth satellites that would cover the entire globe in a matter of a day or a couple of days, but which will lack the revisit rate. Or we can have a geostationary satellite sitting there above the equator and providing very high frequency data, but only for a specific geographical region. Unfortunately, the geostationary satellites are not very well placed to observe the polar regions because of the parallax effect. As we move away from the equator, as you can see on that image at the bottom there, as we move further away from the equator, the pixels get gradually distorted because of the spiral effects that I just mentioned. So it's beyond a certain latitude, the geostationary data is simply not usable for our needs. However, if we're talking about the Arctic, there is a third type of orbits that we can use, and it's a highly elliptical orbit or a Molniya type orbit, if you will. And because of its eccentricity, as the satellite approaches the apogee, it starts moving very, very slowly, providing quasi-geostationary measurements. And that's precisely what we want. We cover the entire Arctic region at a high temporal frequency. And so I thought I'll give you just a little visual indication of that problem that I just mentioned, parallax effect. So this is a blue marble type image from one of the GOES geostationary satellites, a beautiful image. But if we are interested in the Arctic region, we can see, for example, the entire Canadian Arctic above 60 degrees north is essentially compressed into just a few pixels, which makes it quite difficult for us to do all kinds of analysis. What we'd rather want, something that Arctica M satellite does. Arctica M was launched last year in a highly elliptical orbit, and it does provide some of the meteorological data. But it really gives us this Arctic-centric view of the entire region, and it does so at a high temporal frequency. And this is precisely the premise of the Arctic Observer Mission. So this is a mission concept currently in development, under study, should I say, by CSA, and in very close partnership with Environment and Climate Change Canada. So it will provide new observations with unprecedented frequency and density, not only for weather, as in the case of Arctica M, but also greenhouse gas measurements, air quality, and space weather. And it will do so for the entire Arctic above approximately 40-45 degrees latitude using 2 satellites in the highly elliptical orbit that I have just described. We'll have 4 types of payloads on these 2 satellites. Each satellite will carry 4 of these. So a net imager used for weather forecasting, numerical weather prediction, a greenhouse gas instrument, most likely using the imaging Fourier transform spectrometer for the carbon dioxide, methane, and solar-induced fluorescence measurements, a UV-Vis spectrometer for NO2 and O3 measurements, and also a suite of space weather measurements. And each of these payloads would probably deserve a separate presentation at the time that unfortunately I do not have. But I would like to talk just a little bit about the meteorological aspect of this mission. And as you see, I specifically mentioned the advanced baseline imager, and this is the only option we're currently considering for the MAT imager. So ABI is the same type of instrument, or very similar instrument that is currently flying on the NOAA GOES satellites. It has 16 bands and the visible and infrared parts of spectrum, and it supplies radiances that are later integrated into the numerical weather prediction systems at about 0.5 to 2 kilometers every few minutes. And it also has treasure trove of level 2 products ranging from cloud properties to aerosols to wildfire hotspots and so on. So a very capable instrument. So of course the question then, what kind of benefits can we expect from an instrument such as the ABI in a highly elliptical orbit relative to the geostationary satellite? So geostationary data is, of course, very important for weather forecast. It accounts for approximately 20% of the NWEP impact if we're talking about the mid-range forecast of a few days. And it is also a major source of nowcasting guidance. Nowcasting is a relatively short forecast of just from minutes to hour time scale, and it usually goes on top of NWEP and provides better forecasts and monitoring of some of the severe weather events such as hurricanes, snowstorms, but also heavy rain and thunderstorms. So in this context, the highly elliptical orbit would have an NWEP global impact comparable to a geostationary instrument, which is a pretty big deal for NWEP. And the impact will even be higher for nowcasting, since we would have this near real-time observations of the weather. So this is, of course, would be quite important for the indigenous people living in the Arctic there. It will also have a collocated thermodynamic, meaning temperature, pressure, and moisture, and wind measurements in the entire Arctic, also very relevant for NWEP. So this is my little pitch about the mission, and again, just one payload. There are 3 others which I could do a similar thing for. But let me tell you where we are in terms of the mission. So we're currently doing a pre-formulation study with a number of objectives. And the first one is to refine options for the mission architecture, meaning we really want to understand how the mission will function, starting from the payload design to satellite design to ground segment and launch segment, so on. We're also investigating the socioeconomic benefits of the mission, and perhaps the most important, we are actively engaged with our international partners to see if they'll be in a position to contribute something to the mission. So these activities will come to an end towards early to mid 2024 with a budget submission in 2025. And if we are successful with that budget submission, then the anticipated target date is 2034, which is still a few years ahead of us. So I mentioned the international contributions, and it's a very important slide for us because the international engagement is absolutely critical for the success of AOM. So we currently have this international expert team that meets every few months or so, and we have some major players present at the table, including NOAA, NASA, as well as EUMETSAT and ESA. And we also have some letters of support from some of the senior officials from these organizations, which will hopefully set the stage for stronger commitments in the future. But we certainly think that it could be a tremendous opportunity for the international collaboration in the Arctic. So if you're interested in anything I said, please come talk to me. I'll be happy to talk to you. But the more people are rooting for this mission, and the more people are interested in this kind of data, the higher our chances to succeed. So I'm at the end, so this is my final slide, my summary. I don't think I'll go through all of these bullet points, but I do want to mention the very first one. So Canada is coordinating a whole government strategy for satellite Earth observation. In fact, so this satellite Earth observation strategy was published at the beginning of this year, and so it identifies certain priorities and activities, how to best leverage satellite data to fulfill the mandates of the Government of Canada. So it's a very important document for all of us in Canada, and AOM is very well aligned with many of those priorities. So I encourage you to go and take a look at that document if you're interested what the Canadian priorities are. And I'll stop here and see if I can answer any questions.
Yeah, thank you very much.
Just a quick question. Well, this concept is not new, right? I mean, it's been discussed several times. And in fact, I was involved in this very similar proposal to the Space Agency, Canadian Space Agency. And finally, it was refused. And it was never made clear exactly if there was financial or lack of other countries or something like that. Did you ever got a discussion on what made Canadian Space Agency actually now really go in favor of this? Was it any reasons explained? I had heard that there might have been some defense issues, right? That's 5, 6, 7 years ago.
Yeah. Well,
so
maybe,
just curiosity,
sure,
right? That's
sure, you're absolutely right. I mean, this is sort of a reincarnation of the polar communications and weather satellite concept that was pertinent in the beginning of 2010s, I believe. I was not involved in that. Unfortunately, I'm not sure exactly what happened with the PCW concept, I guess, and of course, it has to be aligned with the government priorities. But what I can say is that this mission is really among the top priorities for both the Canadian Space Agency and Environment and Climate Change Canada. And if we do have that international collaboration aspect, I think we are in the best possible position to do the budget ask, and of course, that's the best we can do, and then see what happens.
Sure, like when I saw when you went through all the reasoning and all very good and strong, but the thing that jumped out to me, you talked about the application for atmospheric sciences, meteorology, climate, etc. Why isn't there no marine sciences? Because I could see tremendous value. You mentioned sea ice and that, and I just think this is something in Canada where maybe the Canadian Space Agency focuses a bit more on the atmospheric side, where some of these missions are also of tremendous value to the marine community, and maybe you can get more support by bringing in more links on that side as well.
Sir, I think I missed the key word. So which aspect of the...
I was just thinking, when you listed what I'm saying, I didn't hear the word marine or ocean anywhere in there, and that's where I'm going, why is that? It's going to support it.
Yeah, absolutely. I mean, you're absolutely right. I mean, and the whole point of this, 2.5-year pre-formulation study is actually have more stakeholders coming to the table and talking about the needs and see potential synergies between the measurements. But it is fundamentally the way I listed them. These are really the priorities that were listed: meteorology and greenhouse gas. But certainly there is no reason if we can have measurements that will be useful to you, we'll certainly be keen on hearing from you. Absolutely.
Quick question about the temporal sampling. I think I get the advantage for nowcasting for something like days to weeks. Do you see an advantage of this orbit concept as opposed to polar orbiting satellites where you have like, I don't know, 6 to 10, which give you maybe an image every hour and a half or something, as opposed to maybe 15 minutes here? There, you might not be seeing the advantages of this orbit.
Yeah, I'm not an NWEP expert, but it certainly was studied during earlier stages of this project called AIM North, where that question was trying to be answered. How many satellites do we really need versus a highly elliptical orbit? And that we still came to the conclusion that highly elliptical orbit will be better for this type of applications. And of course, yes, we're absolutely right. We have all those lower Earth orbiting satellites, which are probably doing a good job by ingesting all those radiances and wind measurements. But depending on the nowcasting, if we're talking on the much shorter time scale, then I think HEO orbit will provide us some of the measurements that cannot be achieved with lower Earth satellite at the same temporal frequency.
Okay, once again, thank you very much.
Thank you.